Hello, welcome to episode 188 of Quarkus Insights. So we've got a security focus today. We're going to be talking about CycloneDX SBOMs and also the OWASP Dependency-Track. So with that, I think we can probably introduce our guest, and then we can do the news, and then we can get on to the
I
demo.
think this is the title we have with most like what's it called, like what's it called? I forgot the name now.
Words?
Well, not words, like SBOM, DX, and
Oh, acronyms.
acronyms. Yes.
Yeah.
That was so.
Yeah, you needed to know what was going on with that title to understand that title.
Yeah, but yeah. So there. Cool.
So shall we start with introductions? And do you want to go first, Alexey?
Sure. My name is Alexey. I'm one of the engineers working on Quarkus at Red Hat. I mostly contribute to Quarkus core, not specializing in any specific extension. Well, except maybe I contributed this Quarkus CycloneDX one. And yeah, that's pretty much it.
Cool. And Steve?
Hi, I'm Steve Springett. First of all, thank you to Alexa for bringing us in here and for the Quarkus community for allowing us to present. Greatly appreciate it. Steve Springett, I'm the chair of the CycloneDX Bill of Materials standard, one of the co-leaders of the OWASP DependencyTrack project, which we're going to be talking about both. And then I also sit on the board of directors of the OWASP Foundation.
Excellent. And Niklas?
Yes. Hi, my name is Niklas. I, just as Steve, work for the OWASP Foundation, or work for projects of the OWASP Foundation, namely the projects that Steve created, CycloneDX and Dependency-Track. And I've been contributing to both of them for, I think, 2 or more years, almost 4 or 5 in the case of Dependency-Track. Yep.
Excellent.
Cool. So maybe can we? Oh, go ahead, Chloe.
I was just going to say, I think we probably all want to know what CycloneDX is, but before we do that, we've got a little bit of news, which gives me an opportunity to push the news button.
Awesome.
And so what is our news? Now I've sold too much. Now it's going to be really disappointing.
Well, the news is it's the same old, same old. We have a new release. This time the Quarkus 3.17. Which, well, basically mostly updates, but also a few features. There's a release blog on it. And yeah, stuff like we've added more OpenTelemetry and in some of the WebSockets Next. For those who don't know, WebSockets Next is we've kind of rethought how WebSockets works. And instead of breaking stuff, we added a new extension, which we'll probably see more to in 2025. So no, the 3.17 is there, and even I think we had 1 or 2 updates because there was security issues or severe regression reported. So that has been fixed. Another news is that in December we're going to give everyone some peace and quiet, and at least not have a minor release. There might be other releases, but at least nothing planned because of the new year. And yeah, then we'll be back in January and see how that goes. So yeah, that's the main news from today.
Excellent. And with that, I guess we can jump in.
Yeah. But I'll have the first question. What does DX mean? What does OWASP mean? And there's one more SBOM. I think those are 3 acronyms.
Yeah. Yes. So with that, did you want me to go ahead and dive in, or we want to clear the definitions out first?
If you cover them, that's good. That's good. You can just go ahead and dive in.
All right, let's do that. So thank you again for allowing me to present to the Quarkus community, and for Alexa for setting this all up. We're going to be talking a little bit about CycloneDX. I'm going to provide just a baseline, just to level set the audience, and then I'll get out of the way and let Niklas. I need more caffeine. Let Niklas do a lot of the fun stuff, including some demos and whatnot. But CycloneDX is essentially a software bill, or it's a bill of materials specification. And we're going to be talking a little bit about, why a bill of material versus like a POM XML, for example. What's the difference? Um, it is a project within the OWASP Foundation, OWASP. The OWASP Foundation is a registered 503c3 in the United States. It is a charity. It exists for the betterment of society. Our mission is really to improve the software security of all applications, open source, commercial, etc. And we do that through a lot of different ways, through education and outreach and OWASP projects like CycloneDX and Dependency-Track, and through events, local chapters, regional, and global events as well. So we'll talk a little bit about the OWASP Foundation and perhaps how you can get involved in that if that's something that interests you. But CycloneDX is really a full stack bill of materials specification. It is designed primarily for cybersecurity use cases. However, it actually has one of the most advanced licensing capabilities of any BOM format today. It is widely used. It is estimated that over 100,000 organizations actually use this in their day-to-day. Everyone from financial services to healthcare to world governments, you name it. If there is a organization that really cares about security, cares about license compliance, they typically are gravitating towards CycloneDX. This is kind of a base number to kind of give you some of the scale that we're currently operating at today. We know that at a minimum, these are just ground floor metrics. These are not actual metrics. So ground floor metrics, we know that over 500 million components are represented in CycloneDX every month. This data is provided to us by Sonatype. When Niklas does his demo in a little bit, he's going to be talking about some of the use cases for Dependency-Track. One of those use cases is identifying known vulnerabilities in third-party components. And one of the sources of vulnerability intelligence that Dependency-Track uses is called OSS Index. It's a free service by Sonatype, and that's where these metrics are coming from. So one tool, one source of vulnerability intelligence, 500 million components represented monthly. Mandatory slide of logos. It is community-driven specification. What does that mean? The OWASP Foundation, like I said earlier, is a nonprofit in the United States. We really try to help developers primarily, but others as well, understand and be armed with all the knowledge necessary to create secure and resilient software. We do that through local chapters, projects like CycloneDX and Dependency-Track, and regional and global events as well. No matter where you're at in the world, there's likely a OWASP chapter near you. If you go to owasp.org/chapters, I believe it is, you can actually discover where your local chapter is. They are free to attend. You usually get pizza or whatever. You learn a few things about security, and you have a really good opportunity to network with other people in your area. CycloneDX is an international standard, like JavaScript itself, for example, which is under TC39. Standardization for CycloneDX happens through ECMA TC54, which is Technical Committee 54. A brief overview of what TC54 is. If those who are interested in standardization work, I encourage you to check out tc54.org. It provides a little bit of information on our standardization process, what in fact we are standardizing, because it's more than just CycloneDX, and ways that you can get involved in that. All of these standards coming out of TC54 have a royalty-free patent policy. So you can use the specifications like CycloneDX free of any kind of royalty. In fact, the standards themselves are free. They are not behind like an ISO paywall or anything like that. There are a number of working groups within CycloneDX. Many of those are OWASP groups. We've got everything essentially starts with the community. So we are a community, and we get together and we solve security challenges and licensing challenges. And right now, we're actually working on some patent challenges, and we work on solutions and bring those forward to the rest of the OWASP CycloneDX working groups. I'm going to skip this slide. This is kind of our working model. But TC54 also is involved in standardizing other specifications besides CycloneDX. We are one of the challenges with SBOMs, as we'll maybe discuss in a little bit, is what do you do with them once you have them? Well, one thing that you can do is import them into something like Dependency-Track, but they're really designed to be shared. And how do you share those? Well, TG1 or Task Group 1 is kind of working on that challenge. Task Group 2 is working on standardizing the package URL specification, or Perl. Perl is a new identifier that is used to represent any kind of component, no matter what ecosystem it's part of. And then Task Group 3 is developing a new specification called Common Lifecycle Enumeration, which is really about tracking the lifecycle events of a given product, whether it's software, hardware, doesn't really matter, end of life and the support, but more importantly, provenance and how that changes over time, which is really important for software security. This is the path to standardization that we have. CycloneDX is already an ECMA standard. It's also known as ECMA 424. This is the process essentially that the CycloneDX and all the task groups actually use. When we design CycloneDX, we design for pretty much everything in mind, whether it's applications, the cloud, embedded devices such as medical devices, automotive, aerospace, etc. And we have lots of adopters in each one of these areas, and then some. These are all of the capabilities at a really high level that CycloneDX supports. Today, we're going to be talking just about software bill of materials. So we're going to concentrate on that top cube up there.
So Steve, just a question. You say CycloneDX is a standard, or is CycloneDX implementing a standard?
No, it is the standard.
It is that. Okay.
It is the
For some
standard.
reason,
Yeah.
I thought it was a tool. Okay, it's a standard. Got it.
Yeah, it is the standard. And then we have, as you mentioned, we actually do have a lot of tools as well. So CycloneDX is, actually, let's back up. What is a standard? It's really a human readable document. Historically, they've been either online documents or distributed as like PDFs, for example. So CycloneDX is that human readable standard. Again, that's available on the ECMA website, but it's also an implementation of that standard. We've got multiple implementations of that standard in JSON schema, XML schema, and protobuf. JSON schema is our reference implementation. So that's kind of what the human readable standard is all about. And then we have a lot of tools and libraries that actually implement that standard. So we've got libraries for a lot of different languages, not just Java, but we've got Python and JavaScript, and I think we have some Erlang libraries and a bunch of other things as well. And Niklas actually, who's going to be presenting in a little bit, he's actually the maintainer of the official Go library. So for all the cloud native folks, Niklas's library is kind of what we use for all of those tools. So it is an entire ecosystem. What we wanted to really achieve with CycloneDX is make it really easy for developers to get started without having to read and understand the specification. We wanted it really as turnkey as humanly possible. So we've built this entire ecosystem around the specification, all the tooling, and then you'll see in a later demo from Niklas the actual consumption. Now that I have an SBOM, what do you do with it? And that's going to be the demo that Niklas is going to share with us. But today we're going to be talking primarily about software bills of materials, and just to kind of level set, what is it? Well, essentially, this is an analogy. Now, this is an energy bar, the ingredients on the back of an energy bar. And if I was allergic to tree nuts, for example, this information might be useful to me, right? So it allows me to identify any potential risk that this food product might have to me personally. A software bill of materials is kind of like that. Now, why an SBOM versus like your package manifest, like your pom.xml or package.lock.json or whatever? The SBOM is really the source of truth. The POM and the package lock and everything else are essentially recommendations. There's strong recommendations for what your packages are, not what your packages actually are. Like it is a like I said, it's more of a it's more of a recommendation, and usually it's not your full dependency graph. Your SBOM is in fact an immutable object, and it does usually contain your entire dependency graph after everything has been resolved. So that's really one of the big differences. Um, why SBOMs? Well, SBOMs foster transparency and accountability in the software supply chain. Again, going back, they're really designed to be shared. Now, many organizations share them internally with their own development teams and security teams and legal teams. But you can share them with others in your supply chain as well for procurement, M&A, those types of use cases. In fact, there's a lot of different use cases that SBOMs are useful for. Number one is just inventory management. Just knowing what components you have, what applications you have is kind of essential if you want to start identifying any kind of risk. Obviously, once you have those components identified, then one of the primary things from a security perspective that you can do is vulnerability management. Let's identify vulnerabilities, known vulnerabilities in those third-party components. With CycloneDX, you can do both open source license compliance as well as commercial licensing and commercial compliance as well. You can do vendor risk management. So if you're onboarding a new vendor, get their SBOM. Same for procurement and M&A. I actually use it for M&A all the time because that's what my team does. One of the things that my team does at my day job. Integrity verification, just comparing hashes and other things. You can identify the completeness of that bill of material. How complete is it? Or is there things that maybe you have a jar in there where you actually don't know what else is potentially in there? Maybe it's an Uber jar or whatever. Well, you can actually document that in your SBOM. And then, of course, when we deliver software, it ultimately is put in operation somewhere, right? Well, with CycloneDX, you do have the optional ability to specify additional dependencies, your configuration, all kinds of other things that you might want to specify. So these are the common use cases. Outside of these, there's a ton of other use cases that people use it for. We do have the concept of life cycles as well. So within the CycloneDX, you can actually specify like what part of the life cycle the bill of material was actually generated in. Typically, if you're building software, well, you're going to use the build to life cycle. But again, if you're, doing something in operations, you might actually want to add the configuration and everything else on top of that. And you can specify those different things and different life cycles. So I'm going to skip all of these. These slides will be available. But I do want to mention that we do have some authoritative guides as well. So like I said earlier, we really try to make this as turnkey as possible. And one of the things that we took the time in developing from the community was really these getting started guides. What is currently like the best practices for doing some of these use cases, for achieving some of these outcomes that many organizations want to achieve? Well, we have an authoritative guide series. The first guide that we published was the authoritative guide to SBOM. Again, this is all community written. We've got two other guides in active development, which is the authoritative guide to SASBOM, as well as the authoritative guide to MBOM, which is a manufacturing bill of material, which is essentially how something came to be, right? You can document like how software was created or tested or deployed, how an ML model was trained, evaluated, etc. We also currently have an authoritative guide to attestations and an authoritative guide to cryptography bill of materials. if anyone is interested in participating from the community perspective, here are some links to go check out. And with that, I will pass it over to, is it going to be Niklas? No,
So, yeah,
Alexey.
I'll take it. Yeah.
I just have two questions here, because this actually, yeah, I learned something I wasn't aware of here, or two. So just the SBOM, I thought, was a generic term for both what you call manufacturing and creation and the actual deliverable. Are you saying that the SBOM is just for the what's inside the thing, and what manufacturing is the question? Okay.
Yeah,
so build
it is.
tool
Now,
should not be
CycloneDX
okay.
supports both, right? CycloneDX supports all these different transparency use cases, but the definition of SBOM is really defined by the U.S. government, CISA and NTIA before them, who really defined it as an inventory of your software components that you deliver in a given product, right? So if you're delivering a microservice and you deliver that to customers, what is the inventory of components, both first party and third party, in that thing? Or if you're developing a medical device, right? What does that software stack for that device look like? What is the components that you're delivering? How you build software and all that sort of thing is not part of the SBOM definition, but CycloneDX does support these capabilities. The outside of software in the physical device world, there is a term called manufacturing bill of materials, and it essentially means that if I have a bunch of components and I need to make, I don't know, a smartphone, how can I replicate that smartphone from one factory to another and end up with the identical product at the end, right? Same inside, same packaging, same shrink wrap. It is identical, right? No matter which location. So MBOM is a widely used term in manufacturing, but it does apply to software, right? Because you do need some cases to describe how something was built, deployed, tested, etc.
Got it. Okay. And then the other one, and this is just because, this so far is a lot of, again, acronyms and high level fancy words. Why should I, as a developer, care about SBOM? Like, is this like I'm being a bit on the nose here, but like, why should we care? Like, why this just sounds like someone, that I'm a developer. I just code. Why do I care about the SBOM being a thing?
In an ideal world, you shouldn't. It should be generated and as just part of your build process and consumed by your existing developer tools. And those existing tools should be part of your pipeline. And Niklas is going to go through some use cases for that. But ideally, an SBOM is just a means to an end, right? You shouldn't care about the thing itself. You should care about the outcomes. And those outcomes are identifying vulnerabilities in third-party components, identifying potential licensing things. Your SBOM is just a mechanism to get there. Now, if you do sell to others, and most companies do, you typically might have requirements to share that SBOM with others in your supply chain. So while developers may not care, the business, in fact, may, right? You may have legal obligations to provide the SBOM. Maybe your sales team is selling to one of the world governments, and in order to make that sale, right, you need to provide them an SBOM. So there's many business reasons why you would want these artifacts.
Very cool. Yeah, I'll just add my one. The reason I really became interested in SBOM is that, and I'm sure Alexey is probably going to talk about this stuff, but as a Quarkus developer of delivering software that people use as a runtime, we get so many false positives because there's tools who are trying to guess what's inside based on some loose rule, and I have a faint hope that at least within the next couple of years, hopefully sooner, we can use SBOMs to be more precise on what we include, so we don't get these false positives. But that reality has still not shown itself, but I have hope.
As do I.
But Yeah. So no. But Alexey, go ahead. You're probably going to touch upon this. So.
Yeah, I'll share my screen as well. And well, really, the question that I'm going to try to answer is, as Steve said, CycloneDX is not just the spec, but also is a set of tools. And what I'm going to clarify is why we need yet another one for Quarkus. Okay. So I will use a very simple project as an example, and it's a Maven project. So you could see if I do SBOM.xml, it's a simple Quarkus project with a few extensions, really, just a few dependencies. And as a usual Maven project, you could run Maven dependency tree, and you would see the dependencies of this project. And so the SBOM generators for Maven projects, they work in pretty much the same way. They would analyze dependencies of a Maven project and record them in an SBOM format, right? In this case, CycloneDX. However, this is not exactly how Quarkus sees the same project if it's a Quarkus project. So Quarkus will first resolve this dependency tree, but then it will start to analyze the dependencies, and it will recognize, oh, this one is a Quarkus extension. And then another one here is also a Quarkus extension. And so then it will actually resolve dependencies of Quarkus extensions, but in a bit of a special way. And we have a Quarkus command for that is called Maven Quarkus dependency tree. So this command will actually display the dependency tree that Quarkus will use during the Quarkus build process, because Quarkus itself is a build framework, and essentially it's a build tool that is integrated into another build tool such as Maven or Cradle. And what Quarkus extensions are, if I could use Maven terms to describe them, Quarkus extensions are actually built plugins into the Quarkus framework. So we can find our original dependency that is found in the BOM, for example, Quarkus Hibernate or Panache. But in this Quarkus build time dependency tree, we will also find the corresponding build time artifact called Quarkus Hibernate or Panache dash deployment. And so this dash deployment artifact is a kind of a build plugin for Quarkus framework, and it contains build steps that Quarkus will execute as part of the Quarkus application build process. And the dependency analysis tools that assuming that this project is a typical Maven project, they are unaware of the Quarkus dependency model, and so they don't see this whole other dependency tree and graph that Quarkus sees. And so why this is important? Well, if we have a vulnerability in one of those dependencies that Quarkus resolves behind the scenes, then the vulnerability analyzers might not even see that vulnerability because they will not be able to link that artifact to the project. And I have a very good example. Earlier this year, some time ago, we had a CVE, which, here's the description of this CVE. This is the ID. And well, this description is not very detailed. So if we were very specific about which artifact is vulnerable, it would be Quarkus core dash deployment. And if we did specify it as that, then probably no security scanner would be able to link this CVE to an application, although Quarkus core deployment is a dependency that is present in every Quarkus project. And in this one particular, you could probably read it at some point. It actually, during the build process, Quarkus would record environment variables of the environment where the build was happening and store it in the runtime artifact of your application. So you would be distributing a copy of your environment variables with your application. So it's a very unpleasant one. So that just to illustrate that it's important to be able to analyze these dependencies as part of vulnerability analysis. And so what we need to do to be able to let the scanners know that these dependencies are used, well, we could turn this dependency, well, this is a tree, but we could say that there was a graph, and turn this dependency graph into an SBOM, record it in an SBOM format. And the way we would do it is just, we would say Quarkus Dependency SBOM. And so Quarkus will generate the same information, but in an SBOM format. So if I look at this result, here is the CycloneDX 1.6 version of the dependency. So this goal just manifests the dependencies of the Quarkus application, but all the dependencies that Quarkus would use. So this SBOM contains both runtime dependencies of the application and the build time dependencies. So we indicate the scope with this property, Quarkus component scope. So it's a Quarkus specific one. And in this case, it says this dependency of this artifact, this is the core, is runtime. But if I scroll down, find something at the bottom, you could see that, for example, this component is development time. So it's used during the development phase of the project, but it's not present at runtime, which may help when there is a CVE found in this component. It could help analyze what the impact is of the CVE on the production application, for example. All right, so this one manifests the dependencies of the project. So it records the dependencies that Quarkus will use when the project is being built, right? So if I build this project, Quarkus will use these dependencies. So in a way, we could describe it as manifesting the input into the build, right? We don't know what Quarkus will produce, but we know that Quarkus will use this as input into the build. And so we could use this kind of SBOM to check our dependencies, whether they contain any vulnerabilities before we build our application, right? So if we want to check that before we start the build, we could do this. But if we want to distribute our application and the customer wants to see the SBOM for the application that we are distributing, we will need an SBOM for the outcome of the build. This goal, Quarkus Dependency SBOM, cannot manifest the outcome because the outcome at this phase does not exist. So a way to manifest the outcome would be, we could add an extension, Quarkus extension, add Quarkus CycloneDX. So with this command, I'm adding just another dependency to my project. And if I look now, the pom.xml, I will see this dependency being added. So this is a Quarkus extension. And now when I launch the build now, let's say clean package, skip test. This extension will generate an SBOM for the outcome of the build. So it doesn't matter which packaging type I will use. I could use a fastjar, UBjar, native image. Whatever I choose as the packaging of my application, this extension, whenever I build anything, it will just manifest the outcome of the build. And so in this case, I built a fastjar format, which is not an UBjar. So our distribution will look like this. Okay. So this is not a thin jar. It's a directory layout-based distribution. There are many files. And so here's how the SBOM will look like. Quarkus run, it's called. Okay, so here's how it looks like. So this is the manifesto SBOM for the outcome. And what this means is that we're manifesting the distribution that was built. So when I distribute my application, it consists of multiple files. The consumer of this application should be able to find every file that the distribution contains in the SBOM, and if necessary, we could check that hash sums match, right? That's the whole point. So that when we distribute something, we could verify that it matches the expectation, right? And so here is an example. So this is a file, for example, it's not even a Maven artifact. This is something that Quarkus produced as a file, and we can see that it was properly manifested. And we also use evidence occurrences location to indicate where this file is found in a distribution. This is a relative path relative to the root of the distribution. We also indicate whether it's a runtime or not. So this SBOM also will contain Quarkus build time dependencies. But if I find an example, let me find some example of this runtime. Oh, here is one that is development. So this is a development time dependency. It's not found in the distribution because the distribution contains only the runtime dependencies. But we still manifested that it was used during the build, but there is no location. So it's because that is not found in the distribution, and we indicate that it's development time dependency. One other feature is that sometimes it's not maybe something typical, but it could happen. So Quarkus may modify the original dependency that was included into a build. So for example, I added in my configuration, I added the following application properties. I added the following property. And it really doesn't make much sense, but this is just for illustration purposes. So I decided to remove a certain resource from a jar. So I depend on this Jakarta transaction API, Maven artifact. But for example, I decided that, okay, there is some class or some resource that I don't want to have it in my runtime distribution of my application. So Quarkus allows to remove such resources. It's not a typical case, but it may happen. The reason I'm mentioning that is, so if I build this application, which I just did, right? Quarkus will copy this artifact into the distribution, but it will remove a resource. And what happens when we do this is the hash sum of the original Maven artifact now will not match the hash sum of the jar that is included in the distribution that appears to be Jakarta transaction, right? And so, of course, the dependency analysis and vulnerability management tools will probably highlight that. Okay, we know this artifact should have this hash sum, but in your distribution, this artifact has a different one, so maybe it was compromised. So if that happens, here's what Quarkus does. This is the artifact that manifested in our SBOM. And in this case, we actually add a pedigree and say that this artifact was modified by Quarkus. So it's found in the distribution. It has a package URL of this one, the original one, but it has a note that it was modified. We removed these resources from the original jar. And so the hash sums will most probably not match. They will not match, of course. And so that's pretty much what our tooling does and why we need to develop Quarkus-specific tools to properly manifest what Quarkus does to its distribution, how it builds, what dependencies it's used, and in case it manipulates something. Okay.
Yes, Alexey. So if I understand correctly, right? If you have a need to, well, you should generate SBOM for any Quarkus app, it's better to you add the SBOM Quarkus extension, and then you get this for free, basically, right? That's the
that's the idea, basically.
Yeah.
Yes. Yeah, it's exactly to catch those CVEs if they appear to be built-time dependencies that other Maven tooling is not aware of.
Yeah.
Yeah, we've got a question about whether the dependencies used during tests are also marked as development dependencies.
So yeah, that's a good question. So Quarkus has, may I share my screen again for a bit?
Sure.
Okay. Oh. So, so in Quarkus, we don't really have, when the application is built, we don't really have a rich dependency scope set like Maven does. But we do have different modes to launch an application or build an application. So, for example, if I'm interested in to see dependent or analyze dependencies that would be used during tests, I would do it like this. I would say, let me find an example. Well, if I want to see just dependencies being logged, I would say Maven Quarkus dependency tree D mode test. So by default, the mode is prod, means production dependency tree. If I want test, I would do the test, and then Quarkus will display the test scope dependencies. You can see them here. If I want to generate an SBOM for it, I would basically replace dependency tree with dependency SBOM, and that's it. That will work in the same way. But in the SBOM itself, we will not see test scope. So because now the application will include, test scope will become runtime scope in the test application. That's how also Maven works as well, right? So they will become runtime dependencies of a test application. But yeah, you can do the same. You can do the same with dev. So if you want to see the dev mode dependencies, that's the same way. That's how you would do it. Actually, you can do it. You could generate them all at once. So you can configure the Maven plugin, and you will see them here. Let's do it this way. Oh no, it's not indicated. Okay, yeah. So, but yeah, there is a way. You would need to specify the mode basically, right? And if I build an application, like if I package an application, we don't add the test dependencies to the SBOM that is generated for the outcome.
Cool. So your SBOM wouldn't be contaminated by your test dependencies, but if you wanted to see your test dependencies, you could do the command line flag and then get them
exactly, because the test dependencies are, when you build the application that you want to distribute, the test dependencies do not leak into it. So for a distribution, we just record the dependencies that are relevant for this build of the application, and test scope dependencies are not included in that. You could still you could record the test dependencies using the Quarkus dependency SBOM demo test, and you can also record it. It would be a different SBOM. You could, link them together if necessary.
Cool, thank you. So I guess it's time to switch to Niklas now for the next bit of demo.
Yes, before I start, let me just quickly go back to something that Max said before as to why should I care about this? I'm a developer, I don't care about SBOMs. And I really think that what Alexey has been working on really hammers down on this, because now you can just add this simple extension to your Quarkus build. You don't have to care about anything, you just add it and it's done for you. And what typically happens is what we typically see with Dependency-Track, for example, is developers don't usually touch SBOMs as would anyone else. What happens normally is you build your projects, for example, for a release. That release build produces an SBOM and you send it off to somewhere else. That could be persistent storage, that could be a project like Dependency-Track, or it could be like something else, right? But you as a developer, you don't usually see it happen. So where this all fits into, where Dependency-Track now fits in, let's assume you have a Quarkus application, you build it, you release it, you produce or you added the CycloneDX extension to it, and Quarkus produced this Quarkus run SBOM, right? This deployable SBOM. Usually you would, of course, upload it to Dependency-Track via a CI pipeline, but we will do it in the UI now just for demonstration purposes. So what I should probably say is we as Dependency-Track have adopted Quarkus for our next major iteration for a few services. So we do use this functionality as well. We generate the SBOM and then upload it to GitHub, for example, so that users can download it from there and use it as they want. So the next iteration of Dependency-Track has the code name Hades. That's why I'm using it here. So
shall we share your screen?
Oh, sorry. Yes, please.
Yeah.
Yes.
Oops, sorry. There we go.
Right. So I'm just manually creating a project now. Hades Vulnerability Analyzer, it's called. Oh, I typed vulnerability twice, which is nice. Analyzer, it's the version 0.6. Snapshot. Yeah, so project is created. Now there are different tabs. I will go through them as we discover features, I guess. But the main important part is the components tab. And here you would normally see like the list of all the components in your project. Various options here. You can manually add components if you wanted, but the main use case would be to just upload a BOM. And I will pick the one that I generated with the Quarkus CycloneDX extension for this particular service. Now I can see I have 510 components here. And again, feeding back to what Alexey said, normally if you just take the standard off-the-shelf CycloneDX Maven plugin, you would not see Quarkus deployment components. But now if I search for deployment, like there are various, like I have various extensions in this project, right? So they show up here as the deployment components. But yeah, for the general view here, basic list of components, the version, we have an indicator here if this is the latest version, if there's a newer version available in Maven Central, for example, we show it here with an indicator. For example, for NC regex, there's a newer version available. We also show you when this was published, and Dependency-Track does not only track risk in the sense of vulnerabilities, but also an operational risk, right? A component being old is a risk, a component being horribly out of date is a risk, and a component having a license that does not align with your business is also a risk, for example. There are multiple types of other risks that we can track and identify, but those are like the basic ones. We also
what was the tool called, Niklas? The thing you're showing now, what was that called?
That is OWASP DependencyTrack.
OWASP, okay, got it.
Yep, and the next version has the code name Hades, in case that caused some confusion.
Okay.
Yeah, and then Alexey also mentioned hashes, right, or integrity checks, and we also have this here. In this case, all of it looks good, which is cool. What we do is we look at the SBOMs, the hashes in the SBOM, and then look at, hey, what does the hash look like in Maven Central, or if you have an internal artifact repository, for example, Artifactory, we can look up there for internal components as well. We then compare the hashes and let you know if they mismatch. Again, we also track the licenses that you can use. Yeah, but notably, if we go to the vulnerabilities tab, you will notice there are no vulnerabilities here. And that is because this project is fairly recent. It is built with the latest snapshot version of Quarkus. So good thing there are no vulnerabilities in this thing. I will show you a project with vulnerabilities in a few seconds. But something I missed just a moment ago is you can see these fancy little icons here next to the component name. And they are basically deep links to the dependency graph. I just clicked one of them for Angus activation, and now I'm being brought to all the places where Angus activation is being used. And it's used all over the place, like you can see it's fairly deep in this dependency tree. But yeah, this information is all sourced from the SBOM that Alexey's plugin has generated. Now, just for some basic demonstrations, I will just import an older version of Dependency-Track that has many vulnerabilities, just so we can see the vulnerability analysis part. This is for version 4.8 something. It's like 1 or 2 years old. If I now go back here. Now here I have various vulnerabilities in Postgres, in Guava, in H2, and so on and so forth. One thing about Dependency-Track is it not only shows you these vulnerabilities, it also gives you an ability to audit them or to review them. And this is also where you could suppress them. If any of you or if any of the listeners have heard of VEX before, Vulnerability Exploitability Exchange, it's like in addition to BOMs, if I can say it like that, Steve, that is a fair description. Basically, with the VEX, you can link to components in your BOM and then can make an assertion of the vulnerability or of the exploitability of a vulnerability. So you can say this component is not affected by this vulnerability because the code is not present. And if I, as a vendor, like am distributing this information, I can also say, because it is not present, this code is not present, I will not publish a fix for it. And this information can now be shared with all the downstream consumers, and they know, hey, I don't have to care about this thing anymore because my vendor said so.
So where is that shared? Is that in is that in the recorded in a separate file or like some central database? Is that the VEX database or?
That's a great question. At the moment, you would have to export a VEX file, and that is also, again, CycloneDX. CycloneDX also supports VEX, and then you would send that off to your customers or consumers. But there is an effort, and we had a KoalaCon last week. It's for the Transparency Exchange, or what is the correct name again? Transparency Exchange API, I think. Where this would be all automated, right? Ideally, you would not have to care about those files again. You would just make your assertion and then say, hey, please distribute it to all the people who need to know about it, right? So that is in the works. At the moment, it's a file.
Yeah, because just to give a funny, well, I'm sure it's a funny story, but I say multiple times in the last year or two, you had a case where in the central database, I guess CVE database, there was an issue reported, hey, there's a problem with Quarkus. And we were like, well, that's not really a problem. Like there was a core problem in Vertex that if you use Verting a certain way, yes, then you had a bad problem. And that library was used by Quarkus, but it was never something you would use. Like you had to do something actually to do it, and that got classified like severity 8 or 9 or something. And we were like, no. But that was not actually in the central. But that was because another company made another tool to analyze things, and they classified it as a big thing. And it like that's you have to allow that people can criticize or point out there's an issue. But this fact that there was no way to kind of communicate to anyone that, hey, sure, that's be recognized as an issue, but that's like no need to do a rebuild or risk doing an update because like that's a very very random thing. But that's what I'm hearing, like that's now starting to be a possibility with this stuff, right? The VEX and the transparency and that kind of thing.
Yeah.
But I guess the next time it will just be someone then saying, hey, yeah, sure, but ours is more correct than yours. And yeah. Well, at least you can choose, like, at least communicate it because it is, that's our biggest problem right now. It's not that, like, we can keep up with all the CVEs we are getting, the real ones, but we have a bunch of noise which are just problematic.
Yeah, you can't fix a CVE that you don't actually have.
Yeah, right. Well, you can by releasing a fix that says I'm now fixed, and now people the whole has to pick up, right? Yeah. And that's just yeah. Just while we at it, this just because I've talked with Alexey this a few times in the past on this. Like, so in the community, like Quarkus, we have this way to, like, we now have the SBOMs, so we get a more precise picture. But another one is, like, for example, Red Hat, who is productizing Quarkus. They have basically rebuilds of all the artifacts so they can control and reproduce the artifacts. They are functionally the same, but they have a slightly different version of it at the end. Is there something in the horizon that's going to help me here? Because we have issues of how to say it, where people are running their dependency, like tools like this, against a productized one, and the Red Hat one is either does not include the stuff that is in the community, or we actually fix it in a patch release there. But because it's a slightly different version, and the official ones only record the public, like the ones for community, we get like an error. Is there a way to kind of say that, hey, this is derived from here, but don't report it because it has issues fixed? Would that be possible with this thing too? I'm not sure if this makes sense, but it's like I'm trying to.
Yeah, it does make sense. Like you encounter the similar problem also with Google Assured OSS or something. They also have a project where they manually patch open source libraries.
Yeah, same here.
Yeah. So Dependency-Track at the moment cannot deal with this, but the foundation for it is in CycloneDX. Steve, please correct me if I'm wrong. Because you can record pedigree. Like, for example, Red Hat could record, hey, we changed these parts about this artifact, and we fixed this and this vulnerability in the process. And if Dependency-Track would now get a patch for support of this data, consumers of Red Hat's SBOM could automatically mark those vulnerabilities as fixed. So awesome. Yes, the possibility is there, but Dependency-Track currently does not support it. Hopefully it's on the horizon.
Cool.
It's the producer of the artifact. It's the responsibility of the producer of the artifact to include information to properly manifest what is included in this rebuild. Because if you don't provide information, no one will know, right? So it's the responsibility of Red Hat, Google, whoever rebuilds it, to properly indicate how this one is different from the original version.
But that's the thing is, but there hasn't been a way to do that, right? There's always been like everyone has had their own random tool, or companies made their own thing and they make an assumption on things, and So, but it's good. This is why I care about SBOM. It's like this. There's a possibility that we can actually document to people, hey, like don't use that tool, or rather, if you use this tool, please import the Vex or SBOM data from this place, and everything should be fine. That's I have hopes that it happens before I retire. So it has a few more years.
That's good. I guess we are still in a quite early stage still with all of this stuff. Yes, it works, but it's not the optimal scenario yet.
Yeah.
Any more questions before I move on from this?
I'm good so far. So go ahead.
Awesome. So one additional like vulnerability related use case could be that you are, like, for example, Red Hat, right? You may internally have penetration tests, and maybe someone finds a vulnerability in one of your internal components. Now, with most tools, you would have to either, for example, let GitHub advisories know that, hey, this internal Red Hat component has a vulnerability, and probably you would not want to do this. Or like you are pretty much stuck. You cannot plug internal vulnerabilities in most off-the-shelf tools because they just use a pre-compiled database. But in Dependency-Track, you can add your own vulnerabilities. I'm just going to like put something random here. You have a bunch of options like CVS SV2, CVS SV3, all of these vulnerability management, all of this BS around that. And then you can like specify either CPEs or package URLs for which component is actually vulnerable. And let me just do this here for package maven org Dependency-Track. And then I think it's called KStreams comments. You can either provide a specific version or a version range. Just to make this easier, I'm just going to use greater than 0. Is the name correct? Yes. Then I create this vulnerability. There's nothing to show here because I didn't enter anything, obviously, but I just added a vulnerability for a component in the Quarkus-based Hades vulnerability analyzer project that previously did not have vulnerabilities, right? But now it should have. I click reanalyze, and or did I enter the thing wrong? I think I entered it wrong. Oh no. Let me see.
It's the joy of live demos.
Yeah, it's the adrenaline. Gotta love it. Let's see. Maven, org dependency track, K-streams, comments. This should have. Oh, well. I mistyped the component name. Happens to the best, I guess. Again, critical. And range greater than 0. So if you have internally, or if you have many internal components or libraries that you share across multiple of your internal projects, this is very useful to have. And now hopefully it should work. Yes, thanks. Yeah, so this is basically how you can manage internal vulnerabilities as well. And anything else? Yeah, there's also a policy engine in this. I'm just going to cover some very basic things. For example, I mentioned old components being a risk or an operational risk before, right? Something, if a component was published 5 years ago, maybe you want to know about it. So let's say we create a policy with component older than 5 years. Policies in Dependency-Track are quite basic. You have a quite basic condition editor where you can add multiple conditions and chain them together either via any or all operators. So either any condition matches or all condition matches, and then a policy violation is raised. In this case, I'm going to say if the age of the component is greater than a period of 5 years, we can look at that result later. But we also have, I'm just going to use sluggish names here. We also have a feature where you can type in expressions, and this is a new feature that we are going to introduce. Not only can you have these like predefined conditions, you can also use the common expression language. I don't know if that rings a bell for anyone, but it's a very, very bare bones condition language. It pretty much just evaluates to true or false. It has been adopted by Kubernetes, for example, recently for the admission controls or the admission controller. And the idea is that we give you pretty much access to all the information that Dependency-Track has based on the SBOM you uploaded. For example, one thing you could do is you could create a policy violation if the project is tagged with public facing, and has a vulnerability where the severity is either high or critical, and the attack vector based on the CVSS v3 score is network. So this is probably more of a risk exposure to you than like medium severity in like internal or intranet applications. Yeah, so we try to surface all of the information that we have to the user to leverage for risk management. Now with this enabled, if I just go back here, click reanalyze, I have plenty of components in here that are older than 5 years. Let's look at something simple. For example, this one. Yeah, so this is from August 2019, which is over five years ago, which is crazy to think about. Yeah, but this is what you can do with policies. And policies have a similar audit flow as vulnerabilities. You can like suppress and analyze them and then like store their result, etc. Another, maybe just one last thing for vulnerabilities here. I just showed you how you can go from a project to a vulnerability, but there's also the other way around. So you can also go from, say, you read the news, there's a new CVE published, and you wonder, hey, am I affected by this at all? You can take the CVE, you can go to the vulnerabilities view here, search for it, click on it, and you will see you have one affected project here. And again, there's this dependency graph icon here that swiftly brings you to where this component is located in your project. So there are multiple angles to arrive at the same conclusion, if that makes sense, depending on where you're coming from. There's a bunch more here, but I don't want to stretch the time. Maybe Steve, is there anything I should definitely point out?
No, I think you covered all the basics, sorry, Niklas. So thank you.
Awesome, thanks.
Yeah, thank you. Yeah, very educational, very useful. So, any oh, go on, Max.
Yeah, I'm just saying, very nice. This is yeah, cool. So, and it just this is free and available to anyone, and it just uses SBOM as a raw data.
Yeah,
cool.
It's Apache 2 license, like free as free can be. Yep.
Yeah.
Perfect.
Awesome. So yeah, so why? So just to sneak a quick. So why should I use like? This is competing with like Sneak and others, or is it a complementary, or say like where just to kind of position it?
That's a very good question. Very, very good question. It is not necessarily competing. In fact, we have integrations with Sneak. I was not showing those things in the demo because of time, but we do have a Sneak integration. So if you are a Sneak enterprise customer, you can plug it in here, and we will use Sneak as a source for vulnerability intelligence. And we have like a bunch of other integrations here. Yeah, but
nice.
Probably companies would use either, right? Not both. So either Sneak or Dependency-Track.
Yeah. And there's like the Sonotype have something, and there's a few others we bump into where people go. We get reports. Hey, Quarkus has a lot of CVEs, and we get a 10-page report, and we go look at it, and it's like tools reporting that, hey, Quarkus had for 3 years ago, they had a dependency on this library that has a CVE. And like, yeah, it's been fixed since then. So that's yeah, I'm very hopeful that this will improve that kind of situation, at least over time. So that is very nice.
And we've got a question about whether you have to be connected to the network, or can you run Dependency-Track in an air-gapped environment?
So per default, it like reaches out to Sonotype OS index, but you can disable that. It would try to connect to the NVD to download vulnerabilities, but you can point that to an internal mirror. So the basic answer is you can make it to run into an air-gapped environment, but per default, it is not meant to do that. You can also, like, just because I have this page open now, you can also plug into Trivy. If you have an internal Trivy instance, you can use Trivy for vulnerability analysis. And Trivy also has an air-gapped mode that you can use. Yep.
Cool, makes sense. Thank you. Any other questions from anyone? Going once, going twice. No.
Yep.
No, I
Thank
think
you
we're
all.
good. Yeah, thank you very much. Yeah, really, really useful. See you all.
Thank you.
Have a good day.
Thanks for having us. Bye-bye.
Thank you.
Bye.